Hello, welcome to Samarpit Academy. In this short video, we are going to understand what is the difference between mass and weight. In our daily lives, we use these words interchangeably. But as far as physics is concerned, there is a fundamental difference between mass and weight. They are not the same. So in this video, we will try to understand what are these differences. Now, let me first talk about mass. So what is mass? So mass is nothing but the amount of matter present in a body. So let me write that. Mass is amount of matter present in a body. Now if you take any body, it has some matter. It may be having less matter, it may be having more matter. So any body, if you take, it will have some matter. You measure that amount of matter. That amount of matter is what we call it as its mass. Now, how do we measure this matter? We can measure this amount of matter, that is mass, in different units. For example, if you have a small bodies, we will measure the mass in grams, even smaller bodies, milligrams, big bodies, kgs, quintal, or tons. So, depending upon the mass of the body, we can use suitable unit. So, but what is the standard unit? The standard unit is kilogram, denoted by kg. So what is mass? Mass is the amount of matter present in a body. In standard units, it is measured in kilograms. Now coming to weight. What is weight? Remember, weight is a force. Which type of force? It is a gravitational force acting on a body. So largely I will confine my discussion in this particular video to the context of Earth. So in the context of Earth, what is weight? Weight is the gravitational force acting on a body due to Earth. So let me write here. So this is weight is gravitational force acting on a body. Now this is force. So since this is force, remember, it is, most of you know that it is measured in newtons. So the standard unit is Newton, denoted by capital N. So weight is the gravitational force acting on a body. So when we consider mass and weight, another core difference between them is mass does not have any direction. For example, if I want to specify the mass of some body, I will say the mass of the body is 5 grams or 5 kg or 5 quintal or 5 ton. That's it. The information about mass is conveyed. That means to specify mass, what I have to tell is just the magnitude. How much is the magnitude? That's it. There is no direction for mass. So remember, in physics, there are two physical quantities. That means there are two types of physical quantities. One which don't have any direction, we call them as scalar quantity. Other which have direction, which have magnitude, which obeys vector's laws, they are called as vector quantities. So remember, weight is a vector quantity, whereas mass is a scalar quantity. So when I say scalar quantity, I mean it does not have any direction. But when I say weight is a force. So whenever you're talking of force, whenever you want to specify force, just saying the value is not sufficient. You have to say the direction in which the force is acting. So how does weight acts? So let me explain you that. For example, if I take a flat surface. So let us say this is a flat surface. On this there is a body. So how to show that weight? So weight acts vertically downwards. So this is how we show this weight. So on a flat surface, we can show the weight is acting vertically downwards. So this is how weight acts. And weight is acting from a point. This point we call it as center of gravity. So on a flat surface, if we take the weight is vertically downwards, it is acting from a point. That point is called as center of gravity. Now, if we take Earth as a whole, and let us take some bodies here. So let's say somebody A here. Let's say somebody B here. Let's say somebody C here. Every body will experience weight. Now, in the context of Earth, that means in the context of Earth as a whole, the weight is towards the center of the Earth. That means what is weight doing is, it is pulling every body towards its center. So this is how weight acts. So on D it acts like this, on C it acts like this. So you can see the purpose of weight is to pull every body towards the center of the Earth. That means every body on Earth is attracted towards the center due to the weight. which is nothing but the gravitational force between the body and the earth. So when I say weight, it is a vector quantity, so it has direction. So what is the direction? Either I can write vertically downwards when I'm talking in terms of a flat surface, or I can say towards center of earth. Towards center of earth. So this is the difference. There is one more difference between mass and weight. Now, if you take mass of a body, for example, if you take any body, let's say its mass is 5 kgs. Now, you take the same body to some other location. For example, you can take from equator to North Pole, or you can take from Earth to Moon, or you can take from Earth to Jupiter, any other location. Remember, the mass of the body remains constant. Mass does not change. So, one more difference is mass is constant. That means irrespective of the location, mass will not change. But what about weight? So remember, weight is a gravitational force, and it depends on the planet on which, that means if you take any body, if you put that body on, let's say Moon, let's say on Earth, on Jupiter, depending upon which planet you are placing, its weight can change. So weight can change based on location. So weight can change from place to place. Weight can change from place to place. It depends on the planet's mass. It also depends on planet's radius. So weight depends on the location at which the body is placed. But whereas mass is concerned, mass is not like that. If you place the body anywhere, irrespective of its location, the mass is constant. So this is one more fundamental difference between mass and weight. So you can see I have written 5 differences between mass and weight. So let me quickly tell what are these differences. Mass is the amount of matter present in a body, whereas weight is the gravitation force acting on a body. We measure generally mass, that means the standard unit for measuring mass is kilograms, where the standard unit for measuring weight is Newton. Weight is a vector quantity. That means it has both magnitude, direction, and it also obeys vector laws. But remember, whereas mass is a scalar quantity. That means it has no direction. So what is the direction of weight? On a flat surface, we can say it is vertically downwards, or you can, that means if we consider like a planet or Earth as a whole, we can say the direction of weight is towards the center of Earth. And one more important difference between mass and weight is mass is constant everywhere. That means it does not change from location to location, but whereas weight can change from location to location. Even weight can become zero also. For example, if you take any body towards the center of Earth, the weight of the body will be zero. So weight can even become zero. So I hope you understand the differences between mass and weight. Thank you.